Welcome back to another Everything Dentistry YouTube channel DAT tutorial. Today we're going to be talking about the organic chemistry section in the Survey of the Natural Sciences, and we're going to be talking about aromaticity today. We're going to be determining which one of these structures here is aromatic. So let's jump right into it. One of the first things that we need to consider when we're characterizing aromaticity is the Huckel number of pi electrons. And if you haven't learned this, we're going to go over it right now. The Huckel number is given by 4n plus 2. So this Huckel rule given by 4n plus 2 is a way to determine aromaticity. So if we consider A for a second here, we see that it has 2 pi bonds, which corresponds to 4 pi electrons. So if we were to plug this into this formula, I'm going to give an example right here. So if we do 4n plus 2 equals the 4 pi electrons. Sorry, that's a terrible 2, but we'll roll with it. Equals 4 pi electrons. Okay, so if we could do the math and solve for m, 4 minus 2 is equals 2 divided by 4 is a half. And you have to have whole integers. So A is not aromatic. Does that make sense? Well, maybe we'll run through another one. But you know that the answer cannot be A. Let's look at, for example, C. We'll do the math again. So we see that we have 1, 2, 3, 4 pi bonds, okay? So 4 pi bonds corresponds to 8 pi electrons, because there's 2 pi electrons in every pi bond, okay? So let's do the math again. If you have 4n plus 2 equals the 8. All right, let's check this out. So we know that 8 minus 2 is 6. 6 divided by 4 is 3 halves. So n is not a whole integer. So again, something like C is not aromatic because it does not follow the Huckel rule. All right, so we can go through this B again. 2, 4, 6. 6 minus 2 is 4. 4 divided by 4 is 1. So B for right now is one that we're going to consider. Okay, I'll put a little check mark there. Okay, D, 2, 4, we know that 2 pi bonds is not a Huckel number, so we can go ahead and cross D off. As we can see, we have 3 pi bonds in B. We also have 3 pi bonds in E. So we are going to consider E. So we're considering B and E. We've eliminated all the rest of the options using this Huckel number of pi electrons. Okay, so now we need to go over the characteristics of an aromatic compound. It must be a ring, and it must be fully conjugated. Okay, so as we can see in B here, there is no conjugation between this carbon and this carbon because there is no bond between them. So we know that since this is not a complete ring for B, and it is not conjugated, compound B is conjugated around here, right? But it is not conjugated all the way around the ring. Okay, so that means that it cannot be B. So we are left with E, which is our correct answer. Because we can see that even though it has a nitrogen, it's still a complete ring, and it is conjugated completely around this ring here. So we can say that E has a Huckel number of pi electrons, and it has a complete conjugated ring, which means that compound or structure E is aromatic. So hopefully this helps you navigate these problems better. If you have any questions, please send me an email, which I'll leave in the description below. And please subscribe to this channel for future videos. Thank you very much, and I'll see you soon.